Welcome to the deep dive. I really just want to jump straight in today.
Sounds good. We have a massive amount of ground to cover.
We really do. And I want to talk directly to you, the listener, right off the bat about just the breakneck velocity of the information we're unpacking today.
Because if you felt like the tech landscape was moving fast last year.
Oh, February and early March of 2026 just took the steering wheel, ripped it off the dashboard, and threw it right out the window.
Yeah.
We are looking at a fundamentally rewritten playbook for the future of the global economy.
Completely written.
In a single, roughly 5-week stretch, our sources tracked over $196 billion.
With a B.
With a B, flowing into a very specific, highly strategic sector of the tech ecosystem.
It's just a staggering mobilization of capital. I mean, to put that $196 billion in perspective, we're looking at more liquidity moving in a single month than the entire gross domestic product of several medium-sized nations.
Right.
But, the sheer volume of the money isn't actually the most interesting part.
It's where it's going.
Exactly. The destination, the allocation reveals a massive structural pivot in how the world's most powerful companies view the immediate future.
And that is exactly our mission for today's deep dive. We are here to cut through the deafening noise of generic press releases.
And the social media echo chambers.
Yeah, all of it.
Yeah.
We aren't just looking at a random scattering of tech announcements. We have a massive stack of sources in front of us covering record-breaking venture capital mega deals.
Geopolitical tectonic shifts.
And the launch of frontier models that are fundamentally altering how humans and machines interact. So whether you are prepping for a critical board meeting or trying to rebalance an investment portfolio.
Or you're just insanely curious about what the world's going to look like next Tuesday.
Exactly. This deep dive is your ultimate shortcut. We're going to make you the most informed person in the room.
The overarching theme in these sources is that we have officially moved past the era of generic chat interfaces.
Yeah, the chatbot phase is over.
Right. For the last couple of years, the mental model was conversational. You type a prompt into a text box, and a server somewhere generates text back to you.
Simple back and forth.
But what the data from February and March definitively proves is that we've entered the era of agentic action.
Agentic action.
And hardcore physical infrastructure. The models are no longer just talking to you. They are doing things on your behalf.
And the physical world, the power grids, the data centers, the robots on the warehouse floor is just frantically trying to upgrade to support that software.
Right.
Okay, let's unpack this. Starting with the absolute bleeding edge of the software side. The frontier model arms race is escalating, and we have to start with OpenAI's latest drop.
GPT-5.4.
Yeah, and they released it in 2 variants, right? Thinking and Pro.
They did.
But I don't want to talk about standard benchmark scores. I want to talk about the feature that completely bridges that gap between talking and doing.
The built-in computer use capabilities.
Yeah.
This is the critical leap we've been anticipating. And when we say built-in computer use, we have to be very precise here.
We're not talking about an API.
Exactly. We do not mean it has a specialized API that allows it to talk to a specific application, like a calendar plugin.
Right.
We mean GPT-5.4 can actually operate the native software on your machine exactly as if a human being were sitting in your chair.
Which is wild to think about.
It assumes control of the mouse cursor. It executes sequential keyboard strokes. And it visually parses the interface of any application you have open in real time.
To execute multi-step workflows.
Exactly.
I want to paint a picture for you, the listener, so you can really visualize the workflow implications here. Imagine you have a digital coworker.
Okay.
You don't ask this AI to write a draft of an email for you to manually copy and paste. You say, hey, pull the latest Q3 sales numbers and send an update.
And then you just watch.
Yeah, the AI independently clicks to open Microsoft Excel. It visually locates the correct spreadsheet on your hard drive, highlights the raw financial data, generates a pivot table,
Opens your dashboard software.
builds a visualization, opens your email client, attaches the report, writes the executive summary, and hits send.
All autonomously.
If GPT 5.4 can visually locate a spreadsheet and format a pivot table without crying, it's officially already more useful than I was at my first corporate job.
Well, that visual parsing element is the real breakthrough. It isn't reading the underlying code of the software.
It's literally looking at the screen.
Looking at the pixels, recognizing a submit button, and clicking it. But to make that level of autonomy reliable, OpenAI had to engineer significant under-the-hood improvements.
Like the context window,
Right. GPT-5.4 boasts a 1 million token context window.
which is massive.
It means it can hold and analyze the equivalent of several thick novels,
Hmm.
or an entire enterprise code base in its active memory all at once.
But wait, we've seen large context windows before from other models, and the historical problem is that they often suffer from the lost-in-the-middle phenomenon.
Yes, the needle in the haystack issue.
Right. They remember the first thing you told them and the last thing, but they completely forget the instructions buried in the middle of a massive prompt.
Which is a huge problem.
So how is a 1 million token window actually usable if it's controlling my cursor?
That is exactly the right question to ask, and it brings us to the most crucial metric in the release notes. OpenAI is reporting a 33% drop in hallucinations compared to their previous architecture.
Okay, that's significant.
It is. When an AI is just writing a poem for you, a hallucination is a funny quirk.
Yeah.
You laugh and regenerate the response.
Sure.
But when an AI is actively controlling your cursor,
Right.
opening your accounting software, and sending financial data to your executive team,
A hallucination is a firing offense.
it is catastrophic. That 33% drop in false positives is the mathematical threshold required for enterprise compliance.
And true agentic trust.
Exactly. It means the recall within that 1 million token window is finally precise enough to rely on for autonomous execution.
But OpenAI isn't operating in a vacuum here. Let's look at the immediate counterpunch from Mountain View. Google fired back with Gemini 3.1 flashlight.
A very different approach.
What's so interesting to me is the divergence in strategy. While OpenAI is flexing this massive, heavy-duty cursor controlling capability, Google seems to be optimizing for raw, blistering speed.
And brutal cost efficiency.
The pricing on this is absurd. They are offering it at 25 cents per million input tokens.
It is a brilliant strategic maneuver. What's fascinating here is that Google is engineering flexibility directly into the developer experience.
With the slider.
Yes. They introduced this concept of adaptive intelligence. It's essentially a digital slider built right into the API.
So if you're a developer integrating Gemini into a massive enterprise app, you don't always need a genius-level intellect for every single task. Like, if I just need the AI to moderate toxic comments on a gaming forum, or do basic document translation from Spanish to English, I don't need it to possess PhD-level reasoning.
No, you don't. For those routine tasks, you dial the thinking level slider down. It uses significantly less compute, the latency is virtually instantaneous, and at 25 cents a million tokens.
It saves the enterprise a fortune at scale.
A massive fortune. But if the user suddenly submits a highly complex reasoning problem, say a multivariable calculus equation or a deeply nested coding bug, you dial the slider up.
And the model dynamically allocates more compute to think before it answers.
Precisely.
And we shouldn't let the word light in the name fool us. I'm looking at the benchmark sources, and despite being the light version optimized for cost, Gemini 3.1 scored a 1432 on the Arena.a leaderboard.
Which is highly competitive.
That score actually beat older, much larger models, including Google's own 2.5 Flash in reasoning and multimodal understanding. Plus, it's delivering its first answer 2.5 times faster.
So it's not just cheap.
It's a speed demon that outperforms previous heavyweights.
It really represents the rapid commoditization of intelligence. Google's thesis is that the ultimate winner of the AI race isn't necessarily the company with the single smartest, most expensive model.
Right.
The winner might be the company that makes state-of-the-art intelligence so cheap, so fast, and so frictionless that developers can afford to embed it into absolutely every digital surface on the planet.
Which brings us perfectly to the third major player in this specific arms race, and it's coming out of Europe.
The open source rebellion.
Mistral 3 just dropped, and they are operating on a completely different philosophy than both OpenAI and Google. They train this multimodal, multilingual powerhouse from scratch on a cluster of 3,000 Nvidia H200 GPUs.
The Mistral 3 release is essentially a two-pronged attack on the proprietary giants. On the heavy end of the spectrum, you have Mistral Large 3.
Okay.
This is a massive sparse mixture of experts model. It has 675 billion total parameters.
Let me pause you there, because sparse mixture of experts is a term that gets thrown around a lot in these research papers.
It does.
For you, the listener, trying to understand why that architecture matters compared to a standard model, what is the actual advantage here?
Okay, a standard dense model activates every single one of its parameters for every single prompt.
even for a simple question.
Yes. If you ask it a simple question, the whole brain lights up, which costs a massive amount of electricity and compute.
Right.
A sparse mixture of experts model, or MOE, is like a massive corporation with different specialized departments.
Okay, I like that analogy.
Mistral Large 3 has 675 billion parameters in total, but it operates as a network of smaller experts. When you send it a prompt, a routing algorithm determines which specific experts are best suited to answer it.
So it's not using the whole brain.
No.
Hmm.
Out of those 675 billion parameters, it only activates about 41 billion at any given time. You get the vast knowledge base of a massive model, but the inference cost and speed of a much smaller one.
That makes perfect sense for the data center. But the sources highlight that the real story for the listener might actually be their smaller, dense edge models.
Mistral models.
Yeah, the Mistral 3B, 8B, and 14B. Why is this edge push so crucial? Because right now, most of our AI workflows rely on massive cloud data centers.
You send a request from your phone to a server farm in Virginia, and it sends the answer back.
Right. Mistral's edge models are designed to bypass that entirely and run locally. But I have to ask, if we are pulling this off the cloud and shoving these massive brains directly onto my laptop or smartphone...
Oh, we can hit a wall.
Yeah, a massive wall with battery life and thermal throttling. My laptop already sounds like a jet engine just running a dozen Chrome tabs.
That is the exact friction point the industry is solving for right now. The hardware has to catch up. But assuming you have the right local silicon, which we'll discuss in a moment, running models at the edge solves three massive structural problems for the enterprise.
What's the first one?
First, latency. The speed of light traveling to a server farm in Virginia is fast, but querying a model sitting directly on your local SSD is always faster.
Okay, makes sense.
Second, privacy. This is paramount for the enterprise. If the proprietary data never leaves your physical device, it cannot be intercepted.
And it cannot be ingested into a cloud provider's training data without your explicit consent.
Precisely.
That's huge for legal firms, healthcare providers, anyone dealing with regulated data.
Exactly. And the third factor is cost. By running the inference locally, you bypass the massive cloud compute API fees entirely.
So it's a one-time hardware cost instead of constant meter running.
Right. Mistral is offering state-of-the-art intelligence that you can actually own, download, and run on your own hardware, whether that's an RTX-powered PC or literally embedded inside the local compute module of a physical robot.
And they're claiming the best cost-to-performance ratio of any open-source model currently available.
They are.
So we have a fascinating triad here. OpenAI is building the ultimate autonomous digital employee.
Google is making intelligence incredibly cheap, fast, and scalable via the cloud.
And Mistral is pushing that intelligence out of the cloud entirely, directly onto your localized devices.
But here's the undeniable truth.
What's that?
Absolutely none of this software magic happens without silicon.
Ah, yes.
Every single one of these software breakthroughs is constrained by physical hardware.
Which seamlessly leads us into the biggest bottleneck in the world right now, the hardware and inference explosion.
This represents perhaps the most significant structural shift in the entire global tech industry right now.
How so?
Well, for the last few years, all the breathless headlines and all the billions of dollars were heavily skewed toward the training phase of AI.
Building the brains.
Right. The massive capital expenditures were all about building supercomputers to feed these models trillions of tokens so they could learn.
But what our February and March 2026 sources show is a definitive, aggressive market pivot toward inference.
The models are trained. They've graduated. Now they need to go to work.
And the actual daily application of the model, the inference, is where the real revenue is generated.
Exactly.
Let's look at a fascinating deal that illustrates this shift perfectly. We have a source detailing a massive multi-year agreement between Perplexity and CoreWeave.
Perplexity being the AI search engine that's been making massive waves, challenging traditional search paradigms.
And CoreWeave is a neocloud provider. Under this deal, CoreWeave is deploying NVIDIA's brand new GB200 NVL72 clusters specifically to run Perplexity's Sonar model.
That's a massive deployment.
But here's what I want to know. I track the major cloud players, AWS, Azure, Google Cloud Platform. What exactly qualifies CoreWeave as a neocloud, and why is a major player like Perplexity trusting them with their core infrastructure instead of just signing a check to Amazon?
It comes down to architectural purity.
Purity.
Yeah. The legacy hyperscalers, AWS, Azure, GCP, they built their empires over the last 2 decades by catering to a massive, incredibly diverse range of enterprise workloads.
Right, they do everything.
They have to support legacy databases, web hosting, virtualization, and countless other services. That creates architectural bloat.
Makes sense.
CoreWeave, as a neocloud, built their infrastructure from the ground up for one specific purpose: GPU acceleration and AI workloads.
So no legacy baggage.
None. Their networking fabric, their cooling systems, their storage architecture, it is all hyper-optimized purely for the massive data throughput required by modern AI.
So they strip out all the legacy enterprise bloat and just deliver raw, unadulterated compute.
Exactly. So what here is monumental. CoreWeave is proving that a purpose-built, highly specialized AI cloud can not only compete, but win major multi-million-dollar enterprise contracts away from the established giants.
It proves that inference at scale requires specialized infrastructure.
And it's completely validating the neocloud business model.
And the hardware CoreWeave is using to serve Perplexity's queries, Nvidia's Blackwell architecture.
The new gold standard.
We have the benchmark data from the sources, and it is honestly mind-blowing. Nvidia's GB200 NVL72 just completely smashed the Stack AI financial benchmark.
Smashed it.
They delivered a 3.2 times speed gain over their previous Hopper architecture. But I want to dig into the specific Wall Street data they used for this test because it perfectly illustrates why this matters.
Well, the Stack AI benchmark is grueling. They didn't just ask the AI to generate a creative story.
No.
They took Meta's Llama 3.18b model and force-fed it dense, complex EDGI 10K financial filings.
For you listening, these are the massive, highly regulated annual reports that publicly traded companies file with the SEC.
They are hundreds of pages of dense financial tables, risk disclosures, and management analysis.
Real heavy lifting.
Exactly. On the previous Hopper chips, the system processed 51.5 requests per second.
Okay, 51.5.
On the new Blackwell chips, 224 requests per second.
Wow. If you are a quantitative trader listening to this right now, or anyone managing a sophisticated portfolio, you intimately understand that milliseconds dictate alpha.
Absolutely.
Imagine you have an autonomous AI agent whose sole job is to ingest earnings, call transcripts the absolute millisecond they are published to the wire.
Run deep semantic sentiment analysis to see if the CFO is hedging their forward guidance.
And execute a high-frequency options trade based on that sentiment. A massive system-level improvement in inference speed means your AI executes the trade before your competitor's AI is even finished reading the second paragraph of the transcript.
It is a literal license to print money.
And what's the technical reason for this leap in throughput?
It's a new standard called NVFP4 quantization.
NVFP4 quantization. Break that down for us without getting too lost in the weeds.
Quantization is essentially a mathematical way of compressing the AI model so it takes up less physical memory on the chip.
Like zipping a file.
Similar concept, yeah. The previous Hopper architecture relied heavily on 8-bit precision. The new Blackwell architecture uses 4-bit precision.
So half the size.
Right. NVIDIA's engineers figured out how to squeeze these massive models into half the memory footprint without losing the critical mathematical accuracy required for high-stakes financial analysis.
And because the model takes up less space,
you can push vastly more data through the pipe simultaneously. That is what unlocks that massive 224 requests per second throughput.
So NVIDIA is absolutely dominating the massive data centers. But let's bring it back down to the consumer level, because Apple made a massive hardware push in March that ties directly back to what we were discussing with Mistral's edge models.
Democratization of hardware.
Exactly. Apple announced the MacBook Neo, which they are aggressively touting at a, quote, breakthrough price, alongside a new MacBook Air powered by their next-generation M5 chip.
Apple's strategic posture here is incredibly clear. They are not trying to compete with NVIDIA in the data center.
They're staying in their lane.
They are playing a completely different game. They are vastly expanding the localized AI capabilities of the everyday consumer and enterprise edge user.
By upgrading the neural engines in their M5 silicon?
Yes, and bringing the entry price down with the MacBook Neo. They are ensuring that when models like Mistral's Edge variants or Apple's own localized intelligence features are ready to run locally, the hardware sitting on your kitchen table is ready.
Or in your sales rep's briefcases.
Right. It's powerful enough to handle the inference load without melting down.
It's the democratization of the inference layer. You have Nvidia building the heavy industrial power plants of AI, and Apple is building the high-efficiency engines for the vehicles we drive every day.
That's a great way to look at it.
All right, before we transition into the next piece of this puzzle, I need to step back and level with you, the listener.
This is important.
Very. We are about to look at sources that dive straight into highly charged geopolitical waters. The upcoming segment involves the United States Pentagon, the current presidential administration, and massive national security declarations. I want to make it unequivocally clear right now. Neither of us here is taking a political side.
None whatsoever.
We are not endorsing any viewpoint, policy, or corporate ideology. Our only mission is to impartially map out the exact factual timeline of how this political fallout is drastically rewiring the global technology landscape.
Based strictly on the source material provided.
Strictly on the sources.
So let's look objectively at the timeline regarding the escalating standoff between the Pentagon, Anthropic, and OpenAI.
Where did this start?
The conflict originated when the United States Department of Defense formally requested unrestricted access to Anthropic's frontier AI models.
Now, to provide context, Anthropic already possessed an active $200 million military contract, right?
They did. However, as an organization founded heavily on AI safety principles, Anthropic insisted on strict usage safeguards.
What kind of safeguards?
Specifically, they categorically refused to allow their AI infrastructure to be utilized for domestic mass surveillance operations or for the development and deployment of autonomous weaponry.
Okay, and the Pentagon's response?
The Pentagon refused to accept those operational restrictions.
And the government's response to that refusal was swift and severe. As a direct result of that standoff, the Pentagon officially declared Anthropic a, quote, supply chain risk to national security.
That is a devastating label for any contractor.
Following that declaration, President Trump issued a directive ordering all federal agencies to immediately halt the procurement and use of Anthropic's technology.
Effectively severing Anthropic from one of the most lucrative government sectors in the world.
And the corporate fallout was instantaneous. OpenAI immediately stepped into the void, securing a deal with the Pentagon to provide the unrestricted AI technology that Anthropic had withheld.
This sequence of events triggered a very public, highly contentious corporate clash between the two leading frontier AI labs.
Yeah, this got messy.
Dario Amodei, the CEO of Anthropic, drafted an internal memo to his workforce that subsequently leaked to the press.
What did it say?
In this memo, he sharply criticized OpenAI's decision to assume the contract. Amodei claimed that OpenAI accepted the Pentagon's unrestricted terms because they prioritized placating employees and securing revenue.
Whereas he stated that Anthropic's core mission remained preventing abuses of the technology.
Right. And he went further, accusing OpenAI's CEO, Sam Altman, of offering what he termed dictator-style praise to the current administration to secure political favor.
Altman, predictably, did not stay quiet on the matter. He issued a robust public rebuttal during a keynote at a Morgan Stanley technology conference.
Taking a very different philosophical position.
He stated his belief that the democratically elected government must fundamentally remain more powerful than private corporations. He warned the audience that it is, quote, bad for society if private, unelected tech companies decide to abandon their commitment to the democratic process and the nation's defense simply because they happen to ideologically disagree with the leadership currently in power.
And he pointedly advised Amodei to get his facts right regarding OpenAI's motivations.
What we are witnessing here is a profound philosophical fracture at the absolute zenith of the AI industry.
It really is a chasm. On one side of the chasm, you have the belief that private AI labs, because they understand the existential risks of the technology better than regulators, must act as moral gatekeepers, even if it means defying their own government to prevent hypothetical misuse.
And on the other side,
You have the belief that private companies should not supersede the state apparatus, and that refusing to equip your own military out of ideological disagreement sets a dangerously destabilizing precedent for national security.
it's a debate that is going to define the next decade of defense contracting. And this geopolitical tension isn't just isolated to software contracts.
It's impacting hardware, too.
Heavily impacting the physical movement of hardware around the globe. According to our sources at Bloomberg, the Trump administration has drafted new, sweeping global export rules that would strictly restrict the export of advanced AI chips, specifically those from Nvidia and AMD, anywhere in the world without prior explicit U.S. approval.
The mechanics of these drafted regulations are highly granular and aggressively targeted.
How does it actually work in practice?
Well, if an international enterprise wants to purchase and ship a relatively small cluster, say up to 1,000 of NVIDIA's latest GB300 GPUs, they would undergo a standardized, relatively simple administrative review process.
Okay, 1,000 chips is simple.
However, for massive infrastructure-level deployments, for instance, a foreign entity wanting to procure 200,000 GPUs to build a sovereign AI data center, the friction increases exponentially.
What do they have to do?
The host government of the receiving country would have to get directly involved in the transaction. They would be required to make stringent, legally binding security promises regarding how the compute will be used.
And crucially,
They must permit U.S. government personnel to conduct physical site visits to inspect the sovereign data centers.
that is a massive ask. Allowing foreign government inspectors direct physical access to your sovereign national data centers is an incredible geopolitical concession.
It is. This raises an important question regarding the mechanics of global tech supremacy. The United States is effectively weaponizing its near monopoly on high-end AI silicon as a primary geopolitical lever.
How is the Commerce Department defending this?
They released a statement anticipating the international pushback. They insist this new framework is not a return to the Biden-era AI diffusion rule, which the current administration strongly criticized and rescinded, labeling it as disastrously bureaucratic and overreaching.
So what are they saying this is?
Instead, they state this new approach is strictly about promoting highly secure exports. They point to recent, successful bilateral agreements in the Middle East, specifically massive infrastructure deals with the UAE and Saudi Arabia as the operational model for how the U.S. intends to distribute compute power globally moving forward.
It's the ultimate trump card in international relations. If your country wants to participate in the future of the AI economy, you have to play by the rules of the country that designs the silicon. All right, take a deep breath, because we are now moving into the absolute core of today's deep dive. We are going to dissect the $196 billion capital avalanche.
This is where things get really wild.
We are going to break down the specific mega deals that made February and early March 2026 the most consequential and heavily capitalized period in venture finance history.
When you look at the sheer volume of money across these dozens of deals, a massive, undeniable theme emerges.
What's the theme?
Capital is completely abandoning the shallow end of the pool. Investors are no longer funding generic AI wrappers.
Oh, you know the ones. Those basic SaaS apps that just sit on top of ChatGPT's API and rewrite your marketing copy.
Right. The smart money is hunting for deep tech, hardcore physical infrastructure, and hyper-specific vertical solutions.
Let's start at the absolute peak of the mountain with the Frontier Titans. OpenAI closed the largest private funding round in human history.
The staggering $110 billion round.
That values the company at $730 billion pre-money and roughly $840 billion post-money.
And look who anchored it.
The titans of industry. Amazon injected $50 billion, while Nvidia and SoftBank contributed $30 billion each.
And just shortly before that historic announcement, Anthropic closed a $30 billion Series G, valuing them at $380 billion.
What is absolutely vital for you, the listener, to understand is that these are not just massive cash injections to pay for office space and engineering salaries.
No, these are deeply entangled strategic infrastructure alliances.
Amazon isn't just handing OpenAI $50 billion out of goodwill.
As part of this deal, OpenAI is launching a stateful runtime environment directly on AWS Bedrock, and they are committing to consume massive amounts of Amazon's proprietary Trainium compute silicon.
I want to pause on those two terms because they are crucial. Normally, when you interact with an AI via an API, it's stateless. You send a prompt, it answers, and it forgets you. A stateful runtime environment means the AI maintains a continuous, evolving session on Amazon's servers. It remembers the context across millions of interactions.
Which is the prerequisite for building true autonomous agents that operate over days or weeks.
And Trainium is Amazon's custom-designed AI silicon. So by OpenAI committing to use Trainium, Amazon gets a massive guaranteed customer for their in-house chips.
Effectively validating their R&D and reducing their own reliance on Nvidia.
Exactly. It is a symbiotic ecosystem. And speaking of Nvidia, their $30 billion investment into OpenAI comes with a guarantee of 3 gigawatts of dedicated inference capacity.
They are mutually restructuring the global AI compute supply chain to guarantee their shared dominance.
And when you mention 3 gigawatts of dedicated capacity, it highlights the terrifying, often ignored hidden cost of this entire AI revolution.
Electricity.
These sprawling AI data centers are the fastest growing consumers of power on the planet, and the hyperscalers are finally realizing that intermittent renewable sources like wind and solar alone cannot provide the stable, 24/7 baseload power required for continuous AI inference.
Because if the power blips, the agents die.
Exactly. Look at what Google just did to address this. They purchased a $1 billion iron air battery from a company called Form Energy to power a single data center in Minnesota.
This isn't your standard lithium-ion battery.
No, it uses iron air chemistry, literally the process of controlled rusting and unrusting, to discharge 300 megawatts of continuous power for 100 hours straight.
That solves the multi-day storage gap when the wind stops blowing or the sun goes down.
And on the generation side of the equation, a 2-year-old startup called Inertia Enterprises just raised $450 million to commercialize inertial confinement fusion energy.
The hyperscalers are throwing billions at these deep, speculative hardware bets to solve the energy gridlock. Because if they run out of power, the entire AI revolution stops dead in its tracks.
The energy bottleneck is severe, but the silicon bottleneck is equally critical. Even as Nvidia utterly dominates the high-end data center market, there is a massive silicon rebellion brewing.
Over $1.2 billion flowed into alternative chip startups in a single week in February.
Who are the players?
We have MADX raising $500 million, aggressively claiming their LLM-optimized chips offer 10 times the performance of current standard GPUs.
10 times.
That's the claim. Sambanova raised $350 million and secured SoftBank as the anchor customer for their specialized inference chips in Japan.
And it's not just about matching NVIDIA's raw power. It's about shifting the paradigm of where the compute happens. Axelera AI raised $250 million to build 45-watt edge inference chips.
To put that in perspective for the listener, NVIDIA's data center chips draw upwards of 400 to 700 watts each.
Axelera is building silicon that sips power, designed specifically to run inside cameras, cars, and edge servers.
Then you have Thales, raising $169 million with a wild approach. They are hardwiring specific AI model weights directly into the physical silicon architecture,
claiming they can match inference performance at 1/10 the power consumption.
And Positron AI raised $230 million, claiming their architecture can match the performance of an Nvidia H100 GPU at 1/3 the power.
The market is absolutely desperate for an alternative to NVIDIA's monopoly, especially an alternative that doesn't require a dedicated nuclear reactor to run.
But the absolute wild card in this Silicon Rebellion space is a company called Recursive Intelligence.
Recursive Intelligence. They raised $300 million at a $4 billion valuation.
And here's the kicker. They achieved this valuation just 2 months after they officially launched.
2 months.
The company was founded by elite ex-Google researchers who originally pioneered the use of AI to design Google's TPU chips.
And what are they building now?
Recursive is building a closed-loop AI system that recursively designs better, more efficient AI chips.
It is the ultimate acceleration loop. You use an AI system to design a radically more efficient chip architecture, you manufacture that chip, and then you run a smarter, faster AI on it, which then designs an even more efficient chip.
A $4 billion valuation for a 2-month-old company proves that institutional investors deeply believe this recursive hardware loop is the key to permanently breaking the silicon bottleneck.
Now let's move from the abstract world of data centers out into the physical world. Physical AI, robots, and autonomous vehicles are finally having their breakout commercial moment.
Waymo just closed a jaw-dropping $16 billion round.
They aren't just running cute test tracks in the desert anymore. They are successfully executing over 400,000 fully driverless weekly rides across multiple major U.S. cities.
The commercial robotaxi thesis is officially validated.
And look closely at Wave, an autonomous driving startup that raised $1.2 billion.
What is crucial to note there is the syndicate of investors who led the round: Mercedes-Benz, Stellantis, Nissan, and Uber.
When the legacy global automotive OEMs are leading your Series D, you have undeniable locked-in commercial validation.
The industry has chosen its champion.
Then you have Huawei raising $1 billion and immediately partnering with Uber Freight to commercialize autonomous long-haul trucking.
And we also have Einride taking in $113 million via a PIPE to bring their electric autonomous freight operations to the public markets.
For listeners who usually track venture rounds but might not follow public market mechanics, a PIPE stands for Private Investment in Public Equity. Basically, instead of navigating a highly volatile traditional IPO window, Einride secured institutional private capital at a negotiated price to ensure a successful public float.
It shows that autonomy is aggressively migrating from passenger cars straight into the heart of global logistics.
Autonomy is also migrating into pure robotics and spatial computing. Aptronic raised $520 million to scale manufacturing of their humanoid robots, securing contracts with NASA and major warehouse operators.
Bedrock Robotics took in $270 million with a brilliant go-to-market strategy. Instead of building robots from scratch, they build retrofit kits that turn existing, dumb, heavy construction equipment like legacy bulldozers and excavators into fully autonomous, AI-driven fleets.
Gather AI raised $40 million to deploy fleets of autonomous drones that fly around massive warehouses 24/7, visually scanning and reconciling inventory without human intervention.
And over in China, Juwu Technology raised a massive Series A specifically to build heavy-duty, all-terrain humanoids designed for the brutal environments of mining and construction.
Environments where delicate, U.S.-focused warehouse robots would instantly fail.
To make all these physical robots actually work, they need to fundamentally understand the 3D space around them. That brings us to spatial and core tech.
Xanar hit a $1 billion unicorn valuation after spending 9 years in stealth mode.
They figured out how to use existing 5G and Wi-Fi network signals to achieve sub-meter GPS-free spatial positioning.
This is massive. It means a robot operating deep inside a concrete warehouse or an autonomous vehicle in a downtown urban canyon knows exactly where it is in physical space without needing a clear line of sight to a GPS satellite.
It solves the indoor localization problem definitively.
Alongside them, World Labs, founded by the legendary AI pioneer Fei-Fei Li, raised $1 billion to build foundational world models, giving AI native 3D spatial intelligence so it understands physics and depth, not just pixels.
And Skyrise raised $300 million to build a universal flight operating system. They are literally replacing the incredibly complex mechanical controls of traditional helicopters with AI-assisted, intuitive touchscreen interfaces,
drastically lowering the cognitive load on pilots. It is breathtaking how fast this intelligence is bleeding into the physical realm.
But what about the white-collar world?
The vertical AI layer is methodically rewriting the workflow of every single traditional industry. Let's look at health and biotech.
Okay, rapid fire. Growth Therapy raised $150 million, and TalkU3 raised $210 million.
These are not just lightweight wellness apps. They are robust, AI-assisted mental health platforms that are integrating directly with massive legacy insurance networks to make in-network psychiatry accessible at scale.
Ease Health took $41 million to build an all-in-one AI operating system aimed at unifying the notoriously fragmented software ecosystem used by behavioral health clinics.
8 Sleep hit a $1.5 billion valuation for their AI-powered smart mattresses. And notably, in an era of cash-burning startups, they're actually free cash flow positive.
Moving to deep biotech, Breeze Bio raised $60 million to solve the delivery mechanism bottleneck for genetic medicines targeting type 1 diabetes.
And Flynn.ai raised $20 million to automate the grueling, highly manual process of medical device regulatory compliance.
What we are seeing is AI being deployed specifically to tackle the most highly regulated, high-friction administrative burdens in the healthcare system.
Speaking of high friction, let's talk about legal, GovTech, and defense. LawHive raised $60 million to scale hybrid AI-human legal services.
And I find this next one fascinating. DeepIP took $25 million for a platform that embeds AI patent drafting directly inside Microsoft Word.
Right where the lawyers already work. Think about the implications for billable hours here.
The entire business model of legacy law firms relies on junior associates spending 60 hours drafting boilerplate patent claims.
If DeepIP does that in 14 seconds inside Word, the structural economics of the law firm have to change.
Absolutely. The pyramid structure of professional services is being flattened.
In GovTech, NationGraph raised $18 million, and Forerunners raised $39 million to use AI to navigate the labyrinthine processes of government procurement and municipal climate resilience planning.
And the defense sector has matured into a massive vertical of its own. CodeMetal raised $125 million to build hallucination-free, formally verified AI code translation specifically for aviation and defense contractors.
SMACK Technologies, a startup founded by former U.S. Marines, raised $32 million to build highly classified, domain-specific LLMs for battlefield decision support.
Generic AI models simply do not work in a classified, air-gapped bunker. The military needs bespoke, highly secure intelligence that understands tactical doctrine.
Let's shift to enterprise finance and workflow operations because the disruption here is staggering. Vestwell raised $385 million at a $2 billion valuation to modernize workplace savings plans like 401ks using AI-driven administration to lower fees.
Fundamental hit a $1.4 billion valuation for an architecture specifically designed to analyze massive amounts of structured tabular data.
This is critical because, let's face it, most valuable enterprise data doesn't live in cleanly written text documents.
No, it lives in giant, messy, interconnected SQL databases. Fundamental gives AI the ability to natively understand those databases.
Basis hit a $1.15 billion valuation by automating complex accounting workflows. They already have 30% of the top 25 accounting firms on board, integrating AI directly into their audit and tax prep processes.
And it's not just the massive accounting firms. We've got a stack of workflow disruptions across the board. We've got Turnstile completely rewiring usage-based billing.
Right, because billing in the AI era where you charge by the token or by the compute second is too complex for legacy, static billing software. Turnstile automates that dynamic pricing layer.
Exactly. And then Stacks and Rowspace are raising massive rounds to automate the data layer for content management.
Which is vital for any enterprise trying to keep their localized AI models fed with clean, up-to-date internal documentation.
Then you have Ownwell taking on real estate tax appeals using AI to identify overassessed properties and automatically file appeals for commercial property owners.
Pepper is aggressively modernizing the food distribution supply chain, using AI agents to route trucks and manage perishable inventory.
Accrual is automating complex corporate treasury functions, and Jump is bringing AI-driven compliance directly to wealth management advisors.
Every single niche, high-value workflow is getting its own dedicated AI agent.
But with all of these autonomous AI agents running wild across every industry, a massive new category of infrastructure has emerged to manage the chaos: orchestration and security.
Temporal raised $300 million at a $5 billion valuation. Their entire technical purpose is durable execution.
Explain that.
When you have an AI agent in the middle of a complex 10-step workflow like GPT-5.4, updating an entire database and emailing executives, Temporal ensures that if a server blips on step 7, the agent doesn't just crash and fail. It pauses, recovers, and resumes from exactly where it left off.
Baton raised $300 million for efficient, scalable model serving. Render took $100 million for AI-native cloud infrastructure.
Nimble raised $47 million just to build the real-time data pipelines necessary to keep these agents continuously fed with fresh data.
And obviously you have to secure all of this. Fig Security raised $38 million, UpGuard took $75 million, and Astelia raised $35 million.
Their collective goal is to automate threat detection against the massive new attack surfaces created by AI-generated code and autonomous agents that have direct access to enterprise databases.
Goodfire hit a $1.25 billion valuation focused purely on AI interpretability, literally reverse engineering how these black box AI models make their decisions so heavily regulated companies can actually pass compliance audits.
And then there's Flapping Airplanes, a highly secretive, mysterious research lab that raised a massive $180 million seed round from top-tier VCs for completely undisclosed AI research.
Finally, we cannot ignore the creative layer and the ultimate frontier.
Runway raised $315 million at a $5.3 billion valuation, firmly cementing their grip on Hollywood's generative video workflows and post-production pipelines.
11 Labs hit an $11 billion valuation for completely dominating the global voice synthesis market.
Profound raised $96 million to build the marketing layer for the post-Google era. Their software optimizes brand visibility not for search engines, but for AI answer engines like Perplexity.
Solve AI raised $50 million to allow enterprise teams to generate custom internal software applications using purely natural language.
Letter AI is automating hyper-personalized enterprise sales outreach, and Human is building AI-driven HR platforms specifically tailored for deskless frontline workers.
And pushing the absolute physical boundary, Axiom Space raised $350 million to build the commercial successor to the International Space Station, incorporating AI-enhanced spacesuits and autonomous telemetry for upcoming lunar missions.
Okay. Wow. Take a breath.
That is a lot of capital.
So, what does this all mean? When you step back from the dizzying numbers and look at the sheer scale of the ecosystem we've just mapped out, from an AI autonomously negotiating a patent draft inside Microsoft Word, to a retrofitted robotic bulldozer hauling dirt on a construction site,
To global superpowers fracturing alliances over the safety protocols of neural networks.
the takeaway is undeniable. AI is no longer a cute novelty. It is no longer just a chatbot helping you brainstorm a cover letter.
It has rapidly evolved into the underlying mission-critical infrastructure of the 2026 global economy.
If you connect everything we've discussed today, whether you are a developer dialing in Gemini's thinking slider to save a few pennies on compute, or you're an institutional investor tracking OpenAI's historic $110 billion mega round, the fundamental truth remains the same.
The historical gap between possessing data and executing physical or digital actions in the real world has officially collapsed.
The software can now push the buttons, drive the trucks, and diagnose the inefficiencies autonomously.
I want to leave you with one final provocative thought to chew on before our next deep dive.
Let's hear it.
Consider the convergence of everything we just covered. We are now entering a reality where recursive AI systems, like the one Recursive Intelligence is building, are autonomously designing the very silicon architectures that will run future AI systems.
And models like GPT-5.4 are now independently controlling our cursors, clicking through our software, and executing our workflows.
If the AI is designing its own brain and independently operating the very tools we use to manage our world,
At what point does human oversight shift from actually driving the car to merely sitting in the passenger seat and vaguely suggesting the destination?
think about it.
We'll catch you next time.